Oh, I know you're so excited I'm back. Here we are with the second video from section 3.3. And in this one, I'm just going to cover the logs with special bases. That's common logs and natural logs. So here we go. First, we're talking about common logs. These are logarithms with base 10. When you have log base 10, you generally drop the subscript and just write it as the log of whatever. Here in part A, we have the log of 100. You do not need to put the base 10 there. It's so common that we use that we don't even put that in, and we just, say log of 10, and everyone understands that's a common log, and it means base 10. So let's just go through a couple of these real quick where we evaluate these common logs, and we'll use those same properties from yesterday. They apply to common logs as well as to, just a log with any base. So if you have log 100, think of it as the log of 10 squared. And the reason why I chose 10 here is because, remember, this is base 10, and I want the base and this to match whenever possible. And remember from yesterday, that would just be equal to 2. Same sort of thing here. This is just the log of 10 to the 1/2, because the square root of 10 is 10 to the 1/2. The base and this number here match, the two bases match, so therefore the answer is just 1/2. 1/1000th, let's see, 1000 itself is 10 cubed, but it's put in the denominator, so this is 10 to the -3, so therefore we would have -3 for our result. Again, the base of this is 10, so these cancel each other out here. And then this right here, 10 to the power log base 6 of 6. Well, log base 6 of 6, here you have the base and the number you're taking the log of matching, so hopefully you remember that always equals 1. So this is really just 10 to the first, or 10. Now, going on to example 3, this is just asking us to evaluate these with our calculators. So here I have my calculator, and the first one, we're just doing the log of 34.5. So your log button is over here, log 34.5. And you get this result, and you can round it to the nearest thousandth approximately, so that would be 1.538 we're looking at. If you do the log of 0.43, that gives me negative 0.367. I want to point something out about these. Notice that this first one, I got a positive answer, and the second one, I got a negative answer. Remember, the reason why is because this base is 10. 34.5 is bigger than 10, so you're going to have to raise 10 to a power bigger than 1 to get 34.5. Base is still 10 here. To get 0.43, you're going to need to raise it to a negative power, because it's going to have to be 1/10 to something to get a number that small. So kind of keep that in mind. Now this last one here, log of -3, watch what happens when we put that into our calculator. And I got an error, and it says it's non-real answers. And that's not because there's something wrong with the calculator. That's because you cannot take the log of -3. Think about what that means. If I have log -3, remember this is base 10, and I'm saying, and let's just say I set that equal to x, I'm saying 10 to what power is -3? Well, you can't raise 10 to a power and get a negative number. Also, you may remember, let's see, back here, let me go back a few slides from yesterday. Yep, back. Here we go. On this graph here, remember the log graph? Its domain is only 0 to infinity. You can't have anything less than 0 for this x value here. And up here in this definition, I guess this should really say the x value is greater than 0 for this log. That's what the A was talking about. So you cannot take the log of a non-positive number. You will not get any results. So kind of keep that in mind here. Let me get back to the slide that we're on. So anytime you have the log of a negative number, that's going to be undefined, not possible. Because the domain of the log function is just 0 to infinity there. Okay, moving on. Here we've got just some simple log equations to solve. To solve those, you change the exponential into a log, or if it's a log equation, change it to an exponential. So here we have a couple of log equations, and we're trying to solve for x. So remember, 10 is the base, and then just change to the other form, 10 to the third power equals x. And then we all know that 10 to the third is 1,000. So on that first one, x is 1,000. In this second one, change it to an exponential. This one has a base of 2, and the exponent is 5. So 2 to the fifth equals x. 2 to the fifth is 32. So there's your x value. So just always, be able to change from one form to another. The second special base of logarithms is base e, and these are known as natural logs. So if you're ever talking about log base e of x, no one writes it this way. They all write it like this. Natural log of x is what this stands for. So when you see natural log, and we kind of already talked about this in a previous section, but that means log base e. So you're going to evaluate these just like we did those previous ones, but remember the base of these is e. So the natural log of square root of e is the natural log of e to the 1/2. Remember, base is e, the base of this exponent is e, so those cancel each other out. You just get 1/2. Natural log of e to the 5th, base is e, this is e here, cancel out, that would just be 5. And then here, this is e to the natural log of 4, which is just going to be 4. This follows that property number 4 that we had earlier, which said that if you have b to the power log base b of x, that just equals x. In this case, the base b is e. So we have an e here and we have an e here, log base e, which is natural log of 4. And so that would just be equal to 4 there. Of course, you can also do natural logs on your calculator. So if you go over there, let me clear this out. Our first one here, I don't think I have those written on this sheet for you. Let me show them to you. The first one I want to do is the natural log of 23.5. And then we're going to do the natural log of 0.48. Now, just like before, you should expect that this one's going to be a positive answer and this one's going to be a negative. It's 23.5. You'd have to raise e, which is about 2.718, to a positive power to get that. However, 2.718 to a negative power would give you this really small number here. So on your calculator, that natural log button is right below the log button. So you just do natural log of 23.5 and natural log of 0.48. And you get those two values, 3.157 and negative 0.734. If you try to do the natural log of -5, hopefully you remember what will happen here. We get an error, again, another non-real answer. You can't take the log of any base of a negative number. So this is not possible. And again, that's because the domain of all log functions is going to be 0 to infinity if it's just a basic log function. So -5 is not in that domain there. Down at the bottom of that page, you will see the basic properties for natural logs. These are the same properties that we had before, actually. It's just now they're specific to base E. Remember before we had the property that log base B of 1 is always 0. Here we're pointing out that that's even true for natural logs. Natural log of 1 is always 0. Second property, natural log of E is 1. We had the property if you had log base B of B, that was equal to 1. Here the base is E and this is E that you're taking the log of, so same type of thing. Those cancel each other out, you just get 1. Natural log of E to the Y is Y. That is, like this property, log base B of B to the Y equals Y. And then I just talked about this one over on the previous page. E to the natural log of X is equal to X. So those properties apply for natural logs. They would also apply for common logs. So if you changed every single one of these to common log, this one you would have to change it to common log of 10, that would equal 1. Here if you change this to common log of 10 to the Y, you'd get Y. And here if you did 10 to the common log of X, you would get X. So these properties transcend whatever base you are talking about. All right, now you should be ready to do in your note packet, not your note packet, but your homework packet in section 3.3. After this video, you should be good to go on number 6, 8 through 13, and 15 to 21. Now on the previous one, the previous video, I had said there at the end, you should be able to do also 1 through 5, 7, and 14. So I guess basically you're doing, after these first two videos, 1 through 21. That makes it easier. 1 through 21 on section 3, that's on page 7 of your note packet, of your homework packet, excuse me. Okay, well, hopefully you are good to go on those, and we just have one more video for this section, which I will upload next. Have a good one.